It's time to understand switch logic. We're going to start with a very basic understanding of electricity before we get into the gates. Now, you need to understand switches for a multitude of reasons. One, computer circuit boards work on switch logic. They use transistors, but the concepts that I'm going to teach you are the same. Also, software works on switch logic as well, and I'm going to demonstrate that to you in the gating topics. So let's go ahead. We're going to introduce you to Electricity 101. Now, earlier in this course, you were introduced to switches and the light switch on your wall and the lamp in your room. We wanted you to understand that from the premise of binary. It has a bigger scope to it, though. It's not only an on and off circuit, it's also used in relays and in circuit boards themselves. So let's make sure that we understand before we move on. Power flow. The very first thing you need to understand is power flow. Now, this is something I did not discuss earlier in this course. Power comes from the source, whether that's a nuclear station, some sort of fired coal station, some sort of clean burn facility. That's where power comes from. It could also be a generator outside that is gas powered. It could be hydropower. But power comes through the wires, carried to your home. It then comes into your home, goes through a circuit box. From there, it's wired through your house and comes over to the lights, TVs, electronics, all the various components within your home. When you flip on a switch, the light comes on. When you flip the switch off, the light goes off. For power to flow, it's coming from the source, flowing through those big lines that you see along the streets, or maybe they're underground where you live. They come to your home, they come to the device, but until they get wired to the physical earth ground, power is not going to flow. So the last component of the circuitry is an actual rod, a physical rod that you see here in this picture that is anchored into earth ground, and then the wires are actually connected to that earth ground. That gives it the potential to flow from the source through whatever is completed within the circuitry all the way to ground. So let's explore this a little bit more. Let's take a look at our circuitry so that we can start to understand. This is a circuit that you've seen before. Notice that the switch is set to the on position. And with it in the on position, the light is also on. I've turned on the wires to red to indicate where the power is flowing. Now notice that we have a V that is for voltage. So this is indicating the power source right here, where the power is coming from. But what are we missing? We need earth ground. And this is the symbol that you'll see for ground. And as we just discussed, power flows from the power source through the wires to your house, to the switch on your wall. If you look up right now and see that light switch on your wall, and when you flip that switch to the right direction that it's on, it turns on the lamp in your room or the light in the ceiling. For that to occur, it also has to flow through your home and into that rod that is staked down into the earth ground. So what does that circuit look like? Let's go ahead and pull this up. You've seen this before. Here it is. Notice this is indicating a physical toggle switch, if you will. This is an electrical circuit diagram. So this indicates the switch is down, so power can flow all the way through over here to the output, which in this case just happens to be a light bulb, through to the ground. So this is an on state, a one state, correct? You've learned that before. So power is flowing in this direction and down. Now let's take a look at an off state. So here we see that the switch is off. So if you get up right now and walk over to your wall and flip that switch to an off state, first of all, you're going to be standing in the dark because what happens? The light in the room goes off. Here you can see that the red comes up to the switch, but it does not continue through. The circuit has been broken. And it's indicated right here in the electrical diagram. You can see we have voltage, power flowing in. We get to the switch and up. You can see this one is down. Power can flow through. This one, the circuit is what? It's broken. It's an open circuit. So now you can see that the light bulb is off. We're off here and power cannot flow. It's been interrupted. Just like if you physically went and cut those wires. Or let's say if you needed to see it another way, you could take the power cord on your computer and unplug it. It's the same effect. You've disconnected the circuit. So let's talk about basics for relay logic. This is a diagram showing you a relay. Now let's just walk through this step by step. Don't get lost here. Just stay with me and you'll be okay. This box right here, you see it? I'm drawing it out on the screen. This box indicates a relay. There is a coil. This coil gets powered up. And we're going to talk about that here in a minute. What else is in here? There are switches on the inside. And what gets wired to those are the outputs or the lights or maybe a motor, the TV, your computer, so on and so forth. It's the thing receiving the power, right? It needs that power to turn on or turn off if you disrupt the power. Notice that power flows this way in, and if the circuit is made, in other words, you see that it's a continuous circuit, it's all in red, this light bulb is on, and it comes down here to ground. Notice that this rod is not connecting down here to this circuit, so therefore this side is off, and the light is off. Notice over here, and I'm just walking you through the basic steps, so just stick with me. Over here, we have our light switch, just like on your wall, or the power switch on your computer or your monitor. It's off. And when it's off, power is not going to flow to whatever is downstream of it. Power's coming in. You can see it's red. It gets to the switch, and it goes, oh, I can't get through there. This thing is turned off. The switch is off. I can't get through. So therefore, the coil is off. And this is the state that it would be in. Let me show you what happens when you turn on the relay. All right, so just note, right now, the switch is here. This is on. This is off. Okay, here we go. All right, this is an on relay. Notice that I've got the relay in red. Notice that the light switch is turned on. Notice that the power is flowing through and it has a continuous path through it. With this switch being on, which is closed, it's a continuous circuit all the way to ground, from the source to ground. Now what happens? What I want you to see here is power's coming in. There's this rod, and notice that it's now down. It used to be up here. And this light was on and this one was off. Well, what happened? When this coil turns on, I want you to think about a magnet. If you have a magnet and there's a piece of metal, if you lay that on your table, right, and you get the magnet near it, what happens? That metal's going to slide over to it, right? It wants to be attracted to it and connect itself. And that's what's happening here. This relay turns on, and this rod is actually going to get pulled down. It's coming towards the relay. With magnetism, it's pulling that down, and that's what's occurring here in a relay. So when that occurs, it switches the state of the relay. And notice that power flows here, right? Comes down through the rod, comes through here on the other circuit, and now the other light is on, and the other one is off. Now you're going to say, well, this is red here. It comes up like this. I did not show it going red this way. Power cannot flow through here all the way through. Why? Why can't it flow through to there? Because it's not a complete circuit. That's why. Now, I'm not trying to make you an electronic or an electrical engineer here. I'm trying to just give you a basic understanding of a relay because this is how your computer works. This is how software works. Believe it or not, back in the day, I first started in this business by wiring up relays in different states for automated equipment. We didn't have a computer then on the assembly lines. Instead, there were switches all over the line. So when an operation completed, it would come up, it would hit a switch, which was physically wired. If you can imagine these all chained together in different configurations, some were in series, some were in parallel. If you start thinking about those series, what is that? I need this one. If this switch is on and this switch is on, then power would flow through and it would turn on the light, the motor, whatever was downstream. If I had it in parallel, what would happen? Think about it. What would happen? It would say this switch is on or that switch is on. So either one, and then it would continue downstream. That's how computer circuit boards work as well. So if you can picture your CPU, it has a whole bunch of little circuits on there that are all just little switches. That's it. They're called transistors, but they're actually little bitty relay logic. They're little relays with switches on the inside. They're just electronic, and we call them transistors. They work a little bit differently just due to the state of the transistor, but the concept is exactly the same as what I'm showing you here. So knowing this, you just learned how your computer works. But next we're going to start talking about gates so that you can understand the differences of gates because they relate right back to your programming. So let's just wrap up here with some takeaways. Ready? Power flows when there's a complete circuit and path. Power flows from the voltage source, right? It comes through the source, through the wires, into your home, turns on the lamp, and then flows through to earth ground. And there's a rod in the ground, actually physically connecting it down into the earth ground. When a relay coil is powered on, the switch is pulled to the on state. Okay, I showed you that, right? It physically pulls that switch, that rod arm. And I talked about that relays are the foundation of both software and computer circuitry.